All right, now this is probably the most mind-bendy concept out of all the concepts I've probably given you so far. And this concept, again, object-oriented programming is not specifically about JavaScript or TypeScript. It's a larger, more abstract concept. But today's topic is going to be polymorphism, which is a big word, and we'll get into what that actually means. But poly means many. Okay, morph is shape. Okay, so many shapes. So polymorphism is a technique. It's a characteristic of object-oriented programming, and it is very, very useful, but it takes a while to understand it. So we have to first talk about type. Again, a lot of times beginners tune out the word when I say the word type. They don't quite get what I mean. So again, type is what kind of thing am I working with? Am I working with a string? Am I working with a number? Am I working with a Boolean? Usually when I prompt people with those things, they can try to remember what type is. But type is a very abstract concept because I'm talking about data. Okay, what kind of data am I working with? Now, you may have made this connection, you may have not, but these classes that we've been learning about, they're custom types. So we have types in JavaScript that are built in. String, number, date. Okay, date was a type. Form data. Those are types. They're built in. We didn't have to do anything. They just came out the box. But again, we want to write our own custom apps, so we need to be able to make our own types that we can use. So we've been doing that with classes and interfaces. So for example, I have this class animal, okay? Animal is a type. Okay, something can be an animal. Okay, a variable or a piece of data can be the animal. Okay, an animal class. Okay, so classes are a way to bundle data, like how many legs does the thing have, with behavior, making sounds. So an animal is a thing that has a number of legs. Okay, that's the variable part, and it also is a thing that makes sound. Okay, so we've got our constructor, and then we've got the class animal. This is a very basic class. I've got a property, number of legs, and a method, make sound. So in my app, an animal is a thing that has a certain number of legs and makes sound. All right, now I've got some other classes. I've got my dog class, which extends or inherits from animal. So animal is the parent class, dog is the child class. So remember, when you inherit, you get all the properties. So for example, animal has number of legs. So therefore, because dog inherits from animal, it also gets number of legs. Okay, if you need to be reminded of this fact, you need to go back and look at the previous video on inheritance because it talks about this in greater detail. I'm just reiterating it to kind of refresh it in your mind. But dog inherits from animal, and then this is the part that is unique about dogs. Okay, so dogs are animals, but there's some parts about them that makes them, unique. They're not like other animals. So, for example, is this dog a good boy? Okay, and also notice I'm using an override. So the parent has this make sound function, and the child also has a make sound function, but the child's function does something a little bit different. This is the way that so when dogs make a sound, they go woof, which is different than other animals. Okay, this is a way for me to differentiate dogs from other animals. I also have this cat class, which inherits from animal, and much like a dog, it has an override for make sound for meow, and its property is whether or not it's trapped in the sunbeam. Okay, that's a Boolean. It's either is or is not trapped in the sunbeam. Okay, so you're like, okay, Jonathan, we've talked about inheritance till we're blue in the face. Okay, we've got dog inheriting from animal and cat inheriting from animal. What's the point? Okay, going back to types. Remember I said animal was a type? Well, so is dog and so is cat, correct? They're both types. What if I were to tell you that a dog, okay, is a type dog, but also of type animal because it inherits from animal? So dog is actually two types. It is a dog and it's also an animal. A cat is two types. It's a cat and also an animal. So when you inherit, you also inherit the type from the parent, and that's very, very powerful because that means I can switch these two out for each other in a lot of different ways. Let me give you an example. All right. So first of all, I've got Fido. All right, Fido is a dog. He has four legs, and he is a good boy. Okay, that's what this bullet. See, remember the constructor? I put some basic information about the specific dog. Cat. Okay, Fluffy is a cat with 4 legs, and Fluffy is not trapped in the sunbeam currently. All right, so I've got a dog and a cat, and they're different classes now. They inherit from animal, but dog is a dog class, and cat is a cat class. They're different classes. So I've got this array of animals. Let menagerie, which is an array of animals. Remember, I have the animal type and then brackets to indicate that it's an array. It starts off empty. And look what I'm able to do. I can add Fido to the array, and I can also add Fluffy to the array. But wait a second. Dogs and cats are different classes. How can I add them to the same array? I couldn't do this with other things. So to give you an example, if I do, let's say, example number array, which is an array of number, okay, it starts out, say it starts out blank. I can add numbers to this array. I can say example number array dot push 50. That's fine. That's kosher. But if I do example number array dot push Jonathan, okay, TypeScript yells at me. TypeScript says string is not assignable to number. Okay, when you say that example number array is an array of numbers, the only thing that's allowed to go in there are numbers. You can't put a string like Jonathan into that array. It's not allowed. See how TypeScript will not even let this compile, right? So I'm not allowed to do that. But on line 17 and 18, I put Fido and Fluffy into this same array of animals, and it was fine. TypeScript is not yelling at me. The reason that is because of polymorphism. Okay, dog and cat have 2 types. A dog is both a dog and an animal. Okay, the variable Fido is both a dog and an animal. Fluffy the cat is both a cat and an animal. It's like 2 things at once because of inheritance. And because of inheritance, I can add them to the same array. Okay, this array, really what this is actually saying is this is an array of animals or anything that inherits from animal. Okay, I'm going to repeat that. Okay, let it sink in for a second. The menagerie variable here, okay, is an array of animals. What this is really saying is this is an array of animals or anything that inherits from animal. I'll take either. So if you are of the animal class, obviously you can go into the array. If you inherit from animal, you can also go in the array. I will treat both as the same. So who cares, right? Like, cool, Jonathan, so what? Well, what happens if I want to loop through this array? I can, no problem. So for example, I'm going to do a for loop for let animal of menagerie. I'm going to have them make a sound. So I know for a fact that this make sound method exists on anything that inherits from animal because animal has this method. I know for a fact it's there. So I'm going to go ahead and run this. Yeah, we're right here. I'm going to go to this in the term, OVL in integrated terminal. Okay. To npx, ts node, polymorphism. Okay, so it looped through the array. Fido goes woof, but Fluffy goes meow. Okay, this is a really powerful technique because now I can have classes for dogs and cats, and if I need to treat them the same way, if I need to bunch them together to do something, I can because they're both animals. Or I can treat them separately when I want to treat them separately. I am not boxed in either which way. I can do whatever I want. So with object-oriented programming, one of the things we want to have is some flexibility, right? Because sometimes I might want to deal with cats and dogs together. Now, if it weren't the case that we had polymorphism, this would be very, very difficult to write. Like, I'd have to have an array of dogs and an array of cats. So, for example, you might be thinking to yourself, okay, cool, the parent class, but what if I wanted to do this? So if I wanted to do let dog array is an array of dog, and let cat array is an array of cats. Okay, so the dog array will not accept Fluffy. Okay, because Fluffy is a cat. So these two are treated separately, right? Dog array can only take things that are dogs. Fido, it can take Fido all day long. Cat array can take Fluffy all day long. Okay, but I can't mix. They're separate. If I specifically say dog or cat, then I'm segregating them. But if I'm talking, since they both inherit from animal, I can mix them together by dealing with their parent class. Okay, so I get to choose. I'm not hemmed in by the type I'm dealing with. Okay, this is polymorphism, and this is super powerful and is a technique you constantly use in higher level object-oriented programming because we want to be able to switch objects out with each other in certain circumstances. Typically, it's because they share some sort of functionality. This is a very simple example, but it's not a contrived example. Okay, what I'm basically saying is animals are things that make sound, but I want to let the specific animal tell me what sound it makes. But by putting make sound into the parent class, what's great is that I know for a fact that anything that inherits from animal will make a sound. This kills bugs. This really destroys bugs because I know for a fact functionality is going to be there because I define it there. So you have to think a little bit ahead time when you're designing things. This is why I recommend reading books like Head First Design Patterns or going on YouTube and looking at like Christopher O'Crave. I don't know how to pronounce his last name. But he does a great job in talking about object-oriented programming with design patterns. Okay, so this is all about killing bugs before they ever happen. And that's the power of TypeScript, and that's the power of like classes and object-oriented programming. We can decide what functionality lives where, and because of that, we can be assured it exists. So our program is more likely to run the way we think it will once it gets to be really complicated. All right, but to review, okay, polymorphism, all it means is treating different things that inherit as the same type. So dog inherits from animal. Let's go back here. Dog extends animal. Cat extends animal. Dog and cat both inherit from animals, so therefore they can be interchanged with each other. Dog has two types, dog and animal. Cat has two types, cat and animal. Because of that, I can have an array of animals, and I can put both the dog and the cat, excuse me, line 23 and 24, I can put both the dog and the cat into the same array of animals, and it's perfectly fine, okay? Their TypeScript will allow it to happen. So I can either put them together or keep them separate. It's my choice. I get to decide that. Okay, this is polymorphism, and it also works for interfaces. So if two things share an interface, they inherit from the same interface, you can treat them the same. So classes and interfaces in this way work much the same way. Now we're going to discuss what makes them a bit different, and that's a little harder to explain. It's a little more subtle, okay? But for right now, for polymorphism, as long as you understand that dog inherits from animal, so therefore, and also cat inherits from animal, so therefore I can treat them the same. If you get that part, you're doing really well.